Okay, in this video we're going to look at a couple of different ways of graphing inequalities, or more specifically graphing systems of inequalities, which just means more than one inequality that you graph on the same set of axes. So let's take a look at these two inequalities we have in example number one. Now, for this first method of graphing inequalities, I'm going to be using, I want my inequalities to be in slope-intercept form. So these two inequalities are already in slope-intercept form. That is, they already are in this form y equals mx plus b, or more specifically, y is less than or equal to mx plus b. So they're already in slope-intercept form, which is good. What I want to do next before I graph these is I want to essentially change them from inequalities into equations. So I'm going to go ahead and write this as y equals x plus 2 and y equals negative 1/2 x plus 3. And the only reason I'm doing that is because I know how to graph the equation of a straight line. So I'm going to start out by graphing this as an equation of a line, and then I'm going to go back and do the inequality part. So this first one here, I've got the equation of a line. I know what the slope of this line is. The slope is 1. And I also know what the y-intercept is. The y-intercept is 2. So let me graph the y-intercept first. My y-intercept is going to be 2. So there's a point right there that's on this line. Its slope is, it has a slope of 1, so it's going to be going up like this. So let me graph this like this. I'll go up 1 and over 1. Slope is 1 over 1, which means, so let me just write this as slope is 1 over 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. And I've got some points here. And I just connect up those points, and I have just graphed this line. Now, I don't actually, technically I don't want to graph the line y equals x plus 2. I want to graph the inequality y is less than or equal to x plus 2. So let me go back now to my inequality. Y is less than or equal to x plus 2. Well, all the points on this line are the points where y equals x plus 2. The points where y is less than x plus 2, those are going to be all the points that lie below the line. So all of the points that are in this area down here. So I kind of shade all that in, and this would be the graph of the inequality y is less than or equal to x plus 2. All right, now let's go to this one. Once again, I've got this written as an equation. I just replaced my inequality sign with an equal sign. I know the slope of this equation is negative 1/2, and I know the y-intercept is plus 3. So let me go ahead and put my y-intercept point on here. My y-intercept is this point here, plus 3. My slope now is negative 1/2, which means I'm going to have a line that goes down. And let's see, my rise over run, my slope is 1 over 2. So if I go, let's see, rise would be over 2. Now it's negative, so I'm going to be going down 1 and over 2, which gives me a point right here. I go down 1 and over 2, down 1 and over 2. So here I have some points that are on this line, and I connect up these points. And here's the equation of my line, y equals negative 1/2 x plus 3. Well, now let me go back to my inequality, which is y is less than or equal to negative 1/2 x plus 3. And to graph the inequality part of y is less than negative 1/2 x plus 3, that means I want all of the points that are below this line. In other words, everywhere where y is going to be less than the line. So those points are all these points down here. So in order to graph the system of these two inequalities, that is both of them at the same time, then I just want to shade in the part where I am below this line and below this line, which is going to end up being all of this area down here. And now I have graphed this system of two inequalities. All right, example number 2. Once again, I have two inequalities. And once again, I want to graph these using the slope-intercept form, which means I want them in this form here. And these two inequalities are not already in my slope-intercept form, so I'm going to have to do a little algebra to get them in that form. So let's see, if I want this in the form y equals mx plus b, I want y on this side, I want everything else on the other side. So let me add 3x to both sides. It's going to give me 4y. My 3x's go away. I've got 4y is less than or equal to 3x plus 4. And let's see, I need to divide both sides of my equation by 4. So my 4's will cancel out here, and I've got y is less than or equal to, this will be 3/4 x plus 4 over 4 is 1. So now I've got this in slope-intercept form. Let's put this one in slope-intercept form. This one looks like it's going to be pretty easy. I subtract x from each side, and I get y less than or equal to, let's write this as negative x plus 5. Okay, now I've got them both in slope-intercept form. Let me graph my y-intercept. So my y-intercept for this one, actually let me rewrite these as lines because I want to graph the line y equals negative 3/4 x plus 1. I want to graph the line y equals negative x plus 5. Okay, so for this one, my y-intercept is going to be positive 1. And now my slope here is a positive 3/4, so it's going to be going up. And my rise over run is 3 over 4. So let's see, I'm going to go up 3 and over 4. So from this point, 1, 2, 3, and over 4. 1, 2, 3, 4. It's going to put me here. If I do it again, I would go 1, 2. Well, I'm kind of running out of points here, so let me just use these 2 points. So I connect up these 2 points. And there's the equation of this line. Now again, I don't want just the equation of this line, I want the equation of this inequality. So I want to graph, here I've already graphed all the points where y is equal to 3/4 x plus 1. Now let me graph the points where y is less than 3/4 x plus 1. Once again, that's going to be all these points below this line. So now I've just graphed this inequality. Okay, let's do the same thing here. My y-intercept for this equation is y equals 5. So here's this point right here. Now on this one, my slope is negative 1 or negative 1 over 1. So this one, the line is going to be going down. So from this point, I go down 1 and over 1. There's a point. Down 1 and over 1. There's a point. Down 1 and over 1. And there is my line y, that's my line y equals negative x plus 5. Now I want to graph all the points where y is less than negative x plus 5. Well, those again are all the points below this line that I just drew, so that's all these points here. And now again, since I want to know where are all of the points, where I want to graph the system of equations, so I want to know all of the points that are both below this line and also below this line. So that's going to be all of these points in this region right here. And I've just graphed this system of 2 inequalities. Okay, this last example we're going to do a little bit differently in that I'm not going to put these equations in the slope-intercept form before I graph them. I'm just going to graph them in this form. And the way I'm going to do that is I'm going to graph for each one of these inequalities. I'm not only going to graph the y-intercept, but I'm also going to graph the x-intercept. So let's start with this one. I know my y-intercept. The y-intercept is the point on this equation. In fact, let me go ahead and write it as an equation just to remind myself. First thing I'm going to do is graph this equation. My y-intercept is the point on my graph where my x-coordinate is equal to 0. Well, if I let x equal 0 in this equation right here, then y is going to be equal to 6. If I plug in x equals 0 here, then this term goes away and y is going to be equal to 6. Well, that gives me my coordinate for my y-intercept. X is 0 and y is 6. Well, if I do the same thing to find the x-coordinate, I want to say if y equals 0, then x equals, and so if I take y equals 0 and if I plug y equals 0 in for my y, then I get 2x equals, let me just go ahead and write, then 2x equals 6, which means x equals 3. So my coordinates for this point would be x equals 3 and y equals 0. So 1, 2, x equals 3 and y equals 0 is this point right here. Now that I have these 2 points on my graph, I can just connect up these 2 points. And there's the graph of this line. Now once again, I want this inequality. I'm not just graphing this line, I'm graphing this inequality. So now I have to figure out, do I want to shade in all these points over here, or do I want to shade in all these points over here? So one way to decide which side to shade in is I just pick a point on one side or the other, plug it into my equation, and see if it makes, plug it into my inequality, and see if it makes my inequality true. So let's say I pick a point over here that's kind of easy. Let me pick the origin. Let me pick this point 0, 0. If I plug the coordinates 0, 0 into this inequality, if I let x equal 0 and I let y equal 0, then this whole side of the inequality becomes 0. And then I would have 0 is less than or equal to 6. That's a true statement. Therefore, I know it's this side here that I want to shade in. All right, so now I've graphed this inequality. Now I want to graph this inequality. And again, I want to do it the same way. I want to graph my y-intercept and my x-intercept. So let me do the same thing I did over here. First, let me write this as an equation so I can find my coordinates. Let me find my y-intercept first. I'm going to let x equal 0. If I let x equal 0, then let's see, if x equals 0, this term goes away and I have 2y equals 8, which means that y equals 4. So there are the coordinates for my y-intercept. X equals 0 and y equals 4. So that's 0, 4. There's that point there. Now let me do the same thing to find my x-intercept. I want to let y equal 0. So if y equals 0, then I have 2x equals 8 and x equals 4. So here are the coordinates for my x-intercept. X is 4, y is 0. That's this point right here. So now I have these 2 points on this line, and I can connect these 2 points together. And I've just graphed the equation of this line. Now once again, I'm not just interested in graphing the line, I want to graph the inequality. So I want to pick a point, I want to pick a set of xy coordinates and plug them in and see which side I shade in. Well, once again, let me pick this point here, 0, 0, just because it makes the arithmetic easier. If I plug in the point 0, 0, then this term goes away, and I have 0 is less than or equal to 8, which is a true statement. So this must be the part of my graph that I want to shade in. So for this line, I would shade in this part here. Now, for this example, we also have 2 additional inequalities that we didn't have before. We have the inequality x greater than or equal to 0 and y greater than or equal to 0. And when I add these 2 extra inequalities in here, so now I've got a total of 4 inequalities that I'm graphing. Basically, this one just says if x is greater than or equal to 0, then this is saying I want only positive x values that are either positive or 0, which means, so all my positive and 0 x values are everything on this side of my graph. In other words, everything to the right of the y-axis. This one says let y be greater than or equal to 0, which means everything that's above the x-axis. So with these 4 inequalities, 1, 2, 3, and 4, I'm essentially saying that I'm going to shade in this region right here. In other words, everything that is less than this line, less than this line, greater than this line, and greater than this line. So this region here is the graph of this system of inequalities.